We are from Camarines Norte State College, currently taking Bachelor of Science in Electrical Engineering. Today, as part of our research project 2, we are happy to present to you our research device from a research study entitled IoT-enabled microcontroller-based prepaid electricity metering system with mobile application integration for household energy consumption control. So, this is our device. For the hardware design, we have the external part and the internal part. For the external part, and for the hardware design, we have the external part and the internal part. So this is the internal part.
Diving more to the hardware design of the device, we will first discuss what is outside the device. The hardware design, its external part. Our first component is the light indicator. Since this is an IoT-enabled metering system, the light indicator serves as a connection status display. When the light is on, it means the device is successfully connected to Wi-Fi, enabling a real-time monitoring. If the light is off, it indicates that the device is currently not connected, alerting the user to potential connectivity issues. Next, we have the LCD display. Another convenient feature of our device is that it shows the user's balance in two ways, the remaining balance in pesos and its equivalent in kilowatt hours. This dual display makes it easy for users to understand both their current financial balance and how much energy they have left, allowing for better budgeting and consumption planning. In addition to the LCD, we have also included an analog display as another way to show the remaining energy balance. Lastly, we have the circuit breaker, which serves a dual purpose. It allows users to turn the device on and off while also acting as a protective component. By automatically cutting off power in case of any electrical overload or faults, the circuit breaker helps safeguard both the device and the connected appliances. Another consideration in hardware design is the internal part and the components inside the device. The hardware design, its internal part. First, we have the relay. The relay is connected to the microcontroller used for switching on and off of the components. Next, we have the ESP32 microcontroller, a dual-core microcontroller with integrated Wi-Fi and Bluetooth capabilities often used in IoT applications. A microcontroller board acts as a system's central control unit. It receives and processes data from current sensors and power meters. We also have a buck converter, a type of DC-DC converter that steps down voltage while increasing current that is connected to the microcontroller, used for efficient power management. Contactor, a heavy-duty relay used to switch electrical load that is connected to the output of the device. For the current transformer module, the current sensor is connected to the microcontroller, allowing it to monitor and control electrical loads in real time based on their current consumption. Then for piezo buzzer, it is for the warning feature of the device once the load balance of the device is consumed or zero balance. This audible alert ensures users are promptly notified to reload. Power supply, a device that provides electrical energy to a microcontroller and its components, converting various forms of energy into a usable electrical power. Now, let's move to the software design of the device. Our device uses an app to load and monitor the energy consumption. This is our app and it is called the EnergyNews Smart Meter. The programming language used to turn this research study to life is divided into two. First is for the hardware. It uses JSON, C++, and database. The database is the Firebase Cloud Messaging or FCM that enables reliable and efficient messaging between server applications and client devices. For the software, we have the programming language that is Reactive Native, Expo, Firebase, JavaScript, and the Node. Now, let's discuss the app interface. So, we have two app interface, the admin interface for landlords and user interface for tenants.
To answer the research problem number 2, which is the accuracy, this is the process of the actual testing. But before testing the device, you must take note that the electric meter has a polarity before supplying the power. It is advisable to test a polarity test so that to prevent from short circuit. the connection of the actual electric meter and the device electric meter is in parallel connection so that the reading of both electric meters are synchronized. The load will be plugged into the output of the electric meter and have an interval of 30 minutes to gather the data.
Initial value. Trial 1. For trial 2. And for trial 3. For trial 4. So to summarize the testing results,
So for problem number 3, the features and functions of the device were demonstrated to the target respondents of the study. So for the overall functionality ng device, let's start by turning on the device. So maririnig natin may tumutunog na buzzer indication. Ibig sabihin nito, hindi pa nakakonect yung device sa internet. Now wait natin. Nakita natin done, which is indication siya na nakakonect na sa internet, which is makikita natin dito sa light indication na ito. Now, our device cater 3 major features and function. First is the IoT, then prepaid metering, and application integration na mapapansin natin throughout the functionality of the device. Now, punta naman tayo sa application. So, makikita natin meron tayong dalawang interface, which is the user and the admin, which the admin na gagamitin ni landlord and user na gagamitin ni tenants. So, now, mag-login tayo. So, mapapansin natin sa interface ni user is the balance in pesos and in kilowatt hour, which is conversion lang ng peso to kilowatt. Then, mapapansin din natin na yung transaction, which is the transaction history na nagawa ni user and ni admin. Now, let's go with the admin. Sa admin, makikita niya yung mga accounts ng tenants. And the admin has the power to change the price per kilowatt hour. So makikita natin dito may power din si admin na mag-add ng user and the update the price. Now, let's go with the scenario na pag-add ng balance ni user. Kunwari nagpa-add si user ng 100. So makikita natin dito is the add balance and remove balance. So kung mapansin nyo kung bakit may remove balance. So ginagamit yung remove balance kung sakaling magkamali si admin para mabago niya pa ito. So, let's start by adding. Kunwari nagpa-load si user ng 100. So, makikita natin nagbago yung balance ni user and the kilowatt hour. And makikita rin natin dito sa device. Now, magbawas naman tayo. So, pansinin din natin na our device also has a feature ng pagkakaroon ng update pag may low balance, which is via SMS. So yung device namin na may feature ng pag-notification tuwing maglo-low yung balance ni user. So masasabi natin low yung balance ni user pag yung balance niya is 100 pababa. So pansinin natin dito na magkakaroon ng SMS notification yung user. So bawasan natin yung 202 ng kunwari 105. So yun, 97 na. Ayun, so makikita natin yung notification. So dito naman tayo sa auto disconnection feature ng device na part ng prepaid metering. So sa prepaid metering, pag naging 0 yung balance ni user, is automatic magkakaroon ng service disconnection. So ngayon, bawasan natin yung balance ni user para maging 0. So, ayun. So, maririnig natin yung buzzer na indication siya na wala na siyang balance. And ayun, namatay na yung ilaw. which is an indication na naputol na yung service.
So that end the video demonstration. Through this IoT-enabled prepaid metering system, our goal is to provide a reliable, user-friendly, and secure solution for efficient energy management. We appreciate your time and look forward to receiving your valuable feedback and ratings. Thank you!